to my channel Bal Vigyan Bharati. This is your mentor Avilash Sarkar. Now, in the last class, we have completed the theory of projectiles. Okay, so now we'll continue solving some problem on the projectiles, and in the later classes, we'll move into the some more subjects on mathematics, as I have told already. So now we'll solve some problem on projectile. So this is problem solving on projectile. Okay. So the first one is saying it is a generic problem. So it will relate to some formula that can be used, that concept already that can be used directly in a later cases if it is required. So in a normal projectile motion, what will be the condition of maximum range? What will be the condition of maximum range? Okay, so to understand that, first you have to understand what is about that normal projectile motion. Normal projectile motion is the motion where if something is being thrown from the ground, it will go and hit the ground again. So we have seen it. So if it is being thrown with the initial velocity v0 towards the upwards, so when it is being thrown, it definitely will make some angle with ground, let be theta, at the time it is being thrown. Okay, then after it will follow some trajectory and it will hit the ground again. So there are two things will happen. One thing, it will reach some height, at the same time it will move some distance. So this distance is called the range, and this height is the height of flight. Okay, we can say. So now what happens for the upward motion? What are the changes will happen? There will be an initial velocity towards y direction. Okay, vy0 can name it. There will be initial velocity and the final velocity at this point. If I consider the vertical motion at this point, that will be 0. The final velocity vy final will be 0. Okay, so what is this vy0? And that, if I consider that is the initial velocity along the direction it is thrown, is v0, this is theta, so that means this is nothing but v0 cos theta, and the component at this point is v0 sin theta. This is nothing less. So what we can correlate, y0 is nothing but v0 cos theta, and vx0, that initial velocity at x direction, will be v0 cos theta. Now, as per the theory or the understanding of the projectile, this direction there is no force acting until it is reaching there. So there is no other forces acting in this direction. In the vertical direction, there is the gravitational force acting. Only difference is that, so in this direction there is no velocity change. So what would be my range to? So I will not. I have to consider for the whole journey. I am taking time t, as I said already. So in time t, what is the h height is being covered? Now I am considering this as 0 point. So there is no from the ground, from where I am measuring, this is 0 point. So the h will be what? The total height will be initial velocity v0 sin theta t minus half into gt square as for the case of the motion against the gravity, and other one is initial velocity is the final velocity is 0, so the final velocity 0, the vertical equation, remember v is equal to upward u minus gt against the gravity, so final velocity is 0, u is your v0 sine theta minus g into t. Okay, so time, I'm just the time is the only parameter that will correlate this motion and the horizontal motion. So I want to establish some relation between these two so that everything will be considered to calculate r. Okay, so now, so t is equal to your v0 sine theta by g. So what is the range distance traversed for horizontal motion is v0, the velocity, into time, that is the thing. So now time here, in this case what I am getting is v0 sine theta by g. So can I put it here? So this will be again v0 cos theta into v0 sine theta divided by g. Okay, now what we will get here, range is equal to v0 square into by g is here, and this is equal to sine theta into cos theta. So now v0 square by 2 if I do, so I can bring 2 here also. Okay, so this will turn into v0 square by 2g into 2 sine theta cos theta, in formula you know that is equal to sine 2 theta. So that is the range. So now to be the range, the r could be maximum. So when the r will be maximum, when this is constant, because v0 is the initial velocity, so this is constant, g is a gravitational constant, this is also constant, so this can be written as, so I'm writing it again, the range is equal to some constant into sine of 2 theta, I can write. So r will be maximum when, so now again r max, for r max, what is the value of it to be maximum? This is c into 1, because sine theta, whatever value of theta lies between -1 to +1, so maximum value of sine theta is 1. So only I consider if sine theta is equal to 1, then only it is possible. So the maximum value will be a constant that is equal to v0 square by 2g. But what is the condition? Condition that sine theta tan 2 theta is equal to 1, that means sine of 90 degree, because sine 90 is equal to 1. From there we can write 2 theta is equal to 90 degree and theta is equal to 90 upon 2, that is equal to 45 degree. That means for any normal projectile motion, why it is being said normal? Because there is no other consideration of restriction or force being applied on the system once it is being thrown. So that's why it is called as a normal. The condition should be such that it has to be thrown at an angle 45 degree with the horizontal. So for the same impulse force, the same object will reach the maximum range. Okay, so further will not change. If the impulse only changes, that means if the initial velocity changes, then only the value along with this, the constant sine theta, which is the sine theta maximum value 1, it will change only if v0 changes. So v0 when will change? In case of the impulse force given for particular case increases, then it might give it a higher velocity and it may cross more distance, but the condition for same V0, the angle should be 45 to reach the highest. If I throw it with a smaller angle, or if it is through the higher angle, it will not cross that much distance if it is thrown at a 45 degree. Understood? Okay. So we'll move in the next sum. The next sum, number 2. Let me check what is there. Number 2 problem says, in a normal projectile motion, in a normal projectile motion, what is the condition for maximum height? Now in earlier case it was the range, now in this case the height. So we will consider the same diagram. If I throw it with an angle theta with a V0, okay, now will we call it the same condition that will reach the maximum range? In that condition it will reach the maximum range? No, because as I have shown in the last problem also, if you throw the higher angle it may reach the higher elevation, but it will fall down lesser distance, or if you throw it at lesser angle it will fall down earlier. So in any case the maximum condition for the range is different from the maximum condition of height. So now we have to compute that. So what I have seen, height is equal to, we know that is ut minus half gt square for any motion against gravity. Now here if I put height is equal to, what is u? This is the V0 sine theta. Okay, so V0 sine theta will put here into t minus half into gt square. Okay, this will be the case. But again v is equal to u, this is first equation that I will use and will put it minus gt. So for the for vertical motion the final velocity will be 0 because it is reaching the maximum height. After that, on reaching that maximum height the velocity will be 0. So u is again v0 sine theta minus g into t. So t you know v0 sine theta by g. Now if I put it here, what will I get? H I will get v0 sine theta into v0 sine theta by g minus half into g into v0 sine theta whole square, isn't it? So what will I get after that? So ultimately H is equal to v0 square sine square theta by g minus half into v0 square sine square theta by g. So ultimately it will become half into v0 square 2g into half g into sine square theta. So now it is ended up to that constant, where we can say that for any particular motion v0 is constant, so that means it is sine c into sine square theta. So whether it is sine theta or sine square theta, the maximum value of sine will be what? Sine theta will be 1. But it is ranging between 1 sine theta less than 1. So whether we take -1 or +1, the sine theta is become maximum 1. So can you say that for any projectile motion, if I say either I can take sine theta, means theta is equal to 90 degree, then means if I project it vertically up, throw directly upwards, it definitely will reach the maximum height, because every force is being utilized to reach to the height, and we are not moving towards the we are not moving horizontal any distance, so everything is being converted into the vertical motion. So theta is equal to, if I say 90, or theta is equal to -90, that means, is it possible to throw something minus direction? Because this is a solid surface, I cannot dig it and throw something, so it will not go down, because then it only will, the force will not do any work. So unless it do any work, it will not move. So for only theta is equal to 90 degree, this value is your maximum value, because in that range sin theta is maximum and sin theta is 90 degree. So only consideration that if theta is equal to 90, that means if I throw that object just vertically up without giving any angle towards toward with the horizontal, I can reach the maximum height. So in a normal projectile motion, what is the condition, the maximum height? The condition is that theta must be 90. So theta is 90 means this theta is 90. That means it is making a 90 degree angle. That means the object is being thrown just directly vertically up. Understood? Okay. So going to the next problem, that is problem number 3 will solve. Okay, problem 3. Problem 3 says, in a normal projectile motion, in a normal projectile motion, which of the following quantities has an effect? Which of the following quantities has an effect in calculating the body mass, in calculating the body mass? Okay, the options are given: A, force; B, time; C, velocity; and D, the horizontal range. So in the normal projectile motion, which of the following quantities has an effect on calculating body mass? So what do you think it has to be? Actually, in this the projectile is definitely a part of a kinematics. So where we will not consider the reason of that motion. So that means what I call the impulse force, the impulse force the impulse force, even though it is the reason for starting that projectile, but after it is being used, then after I am considering the motion. When that impulse force is being released, after that we are considering the motion. So that motion in between, except the gravitational force, there is no force is acting. So the gravitational force is what? That is the weight of that mass, or weight of that mass, you can say. So the gravitational force is what? Mass into the g. So this is the force that is affecting that projectile motion. Means once it is being released, then after whatever the trajectory it is following due to this force only, because this is allowing it to fly longer, shorter time, because this will decide how much time it will float on the air, and during that, due to the constant velocity, it has a chance to move some distance. Means if the force of gravity, that means if the mass exactly is smaller, with the same gravitational constant g, it will means experience lesser weight, so it will not give it that chance to move a more height. It will go a smaller height, and so as because it is moving a smaller height, so time of flight is also will reduce, and it is not able to move a longer distance. So the only effective force is the weight, and that will be the choice where only mass is coming. In any other thing, mass is not coming. So it is very straightforward, although you can understand if you have the idea of force. The force is nothing but the force of gravitation, and gravitation is considering the mass with a gravitational acceleration. Okay, so this is a answer. You need not to explain it, but I am explaining to understand it better. You can straightforward give the answer. So this is not a very interesting question, although. Okay, so let me check if anything interesting is there. Then otherwise I will stop it here. In a normal projectile motion, what will... Okay, the number 4 problem will be the next problem, and that is saying in a normal projectile motion, what will be the angle of projectile? What will be the angle of projectile to get horizontal range, minimum. Now in earlier case, if you remember, just two problems before I have shown, the range can be expressed in the formula 2g into sine of 2 theta. Now there I have explained, for any particular motion, v0 can be considered as a constant. So this part is your constant. So this can be written as further sine 2 theta. So for maximum range, what I did, sine 2 theta is equal to I put is equal to 1. So from there I calculated theta is equal to 45 degree. Now range will be minimum when I put sine 2 theta is equal to 0. 0. Sine 2 theta is equal to 45 degree. Now range will be minimum when I put sine 2 theta is equal to 0. 0. Sine 2 theta is equal to 45 degree. Now range will be minimum when I put sine 2 theta is equal to 0. 0. Sine 2 theta is equal to 45 degree. Now range will be minimum when I put sine theta is equal to 0. So now sine 2 theta can be 0 for sine 0, because sine 0 is equal to 0. But whether it is practical to get theta is equal to 0, because theta is equal to 0 means there is no projectile, means I am throwing this towards horizontal, so there is no projectile. Projectile, as per definition, some object been thrown in the air. So to match that concept of projectile, theta I cannot consider, I mean this sine 2 theta, if it is 0, I cannot consider this is equivalent to sine 0. Rather, there are one other option is there. If I consider this is equal to sine 180, because sine 180 is again is equal to 0, isn't it? So sine 2 theta is equal to sine 180, that means 2 theta is equal to 180 and then theta is equal to your 90. So this is possible. How it is possible practically? Let me explain. If I throw the ball up directly, means it is the theta and it is making an angle theta, and I am throwing the ball just up. So that means in that case it will reach the highest height. But whether it will move any distance either side? Practically no, because I am not considering any resistance or any force being acted on the object due to the air or any other case. So practically the way it will go up, it will fall down there itself. So there is no linear movement either side. So that means your range, which I measure on the horizontal distance, is equal to 0. So this could be the minimum, because any further inch or mm will move, that is the more than 0. So 0 could be the maximum, because negative is not possible. Okay, negative is when possible, but when I throw it backward. So because orientation wise this I am considering positive, this is positive x-axis, and as range is a displacement, it is showing a displacement, so this is a vector. So if I consider positive this side, negative must be this side. So in that case, theta again must be more than 90. So that is the different case when I will throw it backward. That could move any further distance in a negative. But when I consider only xy direction, not in the negative, so in that condition, the minimum range is possible is 0, and that will cause due to the theta is equal to 90 degree. Okay, let me check any other problem is there, not otherwise I conclude this class, and in the next chapter I move to the new subject. Okay, let me check it once, any other kind of problem is available. So this is my last problem, number 5. A bullet shot hits the ground 4 kilometers away, which was thrown at an angle, thrown at an angle 30 degree. Okay, now at what angle it must thrown to hit target at 6 kilometers away. So this was the problem. Now here you have to consider there is no resistance due to the air. Now you know the range is what? Range is nothing but V. I call it V0 square by 2g into sine 2 theta. So now for initial condition it has moved 4 kilometers. As per condition 4 is the velocity, 4 is the range, V0 square by 2g, and sine 2 theta is equal to 30 degrees. Sine of 60 degree, then 2 into 30, that is 60. So that means V0 square by 2g into root 3 by 2. So this is the case where we can say that V0 square by 2g is equal to, if I move this will be 8 by root 3. Okay, so just keep it in mind. So what I will get, V0 square by 2g, that is equal to root 3 by 8 by root 3. That I find now. Let me check. Do it once. This is sine 2 theta. This is 4. That is equal to V0 square by 2g is equal to root 3 by 2. So 4. That is okay. Now in the second case, the range is given. The same formula I use, 2g and sine 2 theta if I write. In this case, I have to calculate the theta. So if I have to calculate the theta, then all term I will move to this part. This will be like that. Now range, this case is equal to 6, you know. Now what is that? 2g by v square is equal to just reverse of that, root 3 by 8. So now this is equal to 3 root 3 by 4, we can say. This is again 3 into 1.732 divided by 4. Now if I calculate 3 into 1.732, because root 3 is 1.732, 3 into 1.732 is around 5.1, divided by 4, that is greater than 1, but sine 2 theta is greater than is not possible. This is not possible, that sine 2 theta is not greater than 1. So this is not possible. So that means whatever angle we are just trying to find is not a real angle, but the condition is such that we have arrived here, sine 2 theta is equal to 1, greater than 1. So this, if it is not true, the condition that is given at an angle, if I throw 30 degree will reach 4, that condition is wrong. So we can conclude the condition of the projectile is impossible. The condition of the projectile is impossible. Understood? So this will be the concluding answer. So thank you for now. There could be many more variety, but it is not possible to show everything here. So you try at your home. If in case any problem, you can reach me at any time. You can put message on the comment section. I will definitely will help you to solve those doubts. Thank you for now. Good night.